Welcome to August 24th LeetCode Challenge, complex number multiplication. Given a complex number can be represented in a string of the form real plus imaginary I, where real is a real part of and the integer is in the range between -100 to 100. Imaginary is the imaginary part, where the integers range between -100 to 100. Note that I squared is equal to -1. Given two complex numbers num1 and num2 as a strings, return a string of the complex number that represents their multiplication. So complex numbers, they have a real part and imaginary part. Basically, you multiply them together, and then anytime you get I squared, that's equal to -1. And that's kind of the property of complex numbers, at least the general basis of it at least for multiplication. So I guess a lot more difficult when you have to do like division and stuff like that. So you have num1, which is, let's see, 1 plus 1i plus 1 plus 1i. And if you multiply those two together, you get 2i, basically 0 plus 2i. So some explanation here is basically you do kind of mathematical operations. You do, let's see, 1 times 1, you get 1. 1 times I, you get I, plus 1 times I times 1 again, right? Then you get I times I squared. So we get I squared. So therefore, you get basically, yeah, so you get 1 plus 2i plus 2 times I, which is if we do the mathematical interpretation of that. So for instance, I guess this is basically I squared. I2 is I squared, so I2 becomes -1. -1 plus 1 is 0, and then you get 2 times I. Wow, this is so if you represent as a string, basically you have to do 1 plus -1i times 1 plus -1i, and that's going to give you the string here. Ideally it represents -2i, but you get this weird format here. The same deal as before. So imaginary complex number multiplication is pretty simple if you do it on paper and math wise, but to do this, it's basically a simple mathematical string computation. So it's not too bad. Let's split up the two numbers. So we know that the imaginary part and the real part are split. You can split them apart using the split operator. So let's do that. A, B. So when you take num1, you want to split it up via dot split with the plus sign. Likewise, do the same thing to C, D. And take num2, we split that as well. Dot split. You want to split it by the plus sign. All right. So now that you split it, next thing you want to do is you want to basically take the real parts, multiply them together, take the imaginary parts, multiply them together, and also you want to take the imaginary of the first part times the real of the second part, and the imaginary of the second part times the real of the first part. So let's just call this RE for real, and you want that to be an integer multiplication, so integer of A times the integer of C. So basically the first real number of the first part times the first real number of the second number, and you want to basically minus, follow along here, I minus the integer of B dot split, just in case it doesn't have a value in front of it, by I. Let's see, I. The first index of that times the integer of the second part D dot split by I as well. Split. I. Take the first part of that. Alright, that's the real part right there. And the imaginary part, called the IM, will be a similar type of situation. You have, let's see, integer a times the integer of d dot split, and you want to split that at the I position, or where the location of I is. Take the first index of that, and then that's all together plus the integer of c times the integer of b dot split at I as well. First index of that. So right now you have two numbers here, and you want to return a string. So this is going to give us our real part and imaginary part. Now we just need to return this as a string in the right format. So it'll be a string of the real part, concatenate it with the addition operator, concatenate it with the string of the imaginary part, plus concatenate with I. Whew. Let's see if this works. Awesome. One good side is that even if you have 0i, it'll still generate 0i. So this all you need to do is just basically simple complex number multiplication with the real imaginary parts by breaking them down, and then put them back together after doing the arithmetic for it in integer format, and then convert them back to string. Time and complexity would be big O of constant time, because you're only splitting the number input, and then these are multiplications, and yeah, they happen in constant time. So no matter how big the numbers are, it'll be constant space as well. Well, linear space and linear time, I should say. Yeah. No, not linear. Constant space and constant time. All right, that's it. Have a great day, guys.